Hey, math friends. So our lesson today and our learning target is I can determine if a relationship is what's called proportional. We're going to check using a table, a graph, or an equation. The other term for that in like Minnesota State standards is that if it's in direct variation. So a proportional direct variation, that really is the same language. So today's lesson is more about yes, it is or no, it's not. So it's a little bit more of yes and no and less about really showing work. So that might make some of you happy. But what is direct variation is kind of the first question here. And again, direct variation means proportional. So we're talking about, it means that it's the ratio of one quantity to another is what we call a constant. So it's the constant or that the unit rate is the same, that the unit rate is the same. So the equation would look like this, that this k is constant for the entire growth of it. You'll notice that if we come out of y equals mx plus b, something we just talked about, that this b is really a plus 0 in that scenario. So you can see that we're not representing that there, which means that in order to be in direct variation, you have to be going through the origin. So your y-intercept would have to be 0. That's just a really good starting point for you understanding. And then this, of course, is your slope, or something known as the constant. All right, so we're going to tackle this today, and really the big heavy hitter of today's lesson is that in order for it to be in direct variation, that your plus b has to be 0. So that's, if you know that going into the lesson, you will have success with this lesson. So what's another name for direct variation? We covered it at the very beginning. It means that it is, apparently I can't get that to work there. It means that it's proportionate. I'm just going to rewrite it. So it means that it's proportionate. All right. And again, that just means that we have a y equals mx plus 0. That means it's going through the origin. So that will not be written today in our work today. Okay, so let's take a look. Pretty quick lesson here. So how do you know if a graph, because I'm going to start with graph because I believe it's the easiest to identify. How do you know when a graph shows direct variation? Well, in order for it to be direct variation, we have to go through the origin because the plus b has to be 0. So we simply just look at the situation. This line here, it does go through the origin, so we say proportionate. This line here, it does not go through the origin. Here's our origin. Does not go through the origin, so we would say not proportionate. So it's a situation where we simply are just looking to see, does the line go through the origin? It does here. It does not there. So that's all you have to do for a graph. So we would say, yep, proportionate. Nope, not proportionate. Does it go through the origin? Tables, they're very similar to graphs in that we can even look in the table, either look in the table or you can graph it. So all points have to have the same constant in the table. So what you could do is you could go and represent y divided by x all the way through, but that takes quite a bit of time to do that and make sure they have the same constant. So instead, I recommend graph it and see if it goes to the origin. So first data point is right 1, down 1. So right 1, down 1. The next data point would be right 2, 0. The next data point would be right 3, up 1. The next data point would be right 4, up 2. And we would graph the line. Does this line go through the origin? No. So we would say that this table is not proportionate. Does not go through the origin. So that's how we check a table. So we covered how we check a graph. We covered how we check a table, and now we're going to cover how do we check an equation. This is by far the more complicated of the three, so I saved this one for the last. So the steps basically here would be this. If you already have y equals, then jump to step 3. If you do not have y equals, then solve it for y and jump to step 3. So again, most complicated of the entire lesson. So our job is to build a house around y and add 3, copy, paste. So our job is to get y alone because we're trying to get in the form of y equals mx plus b. And what we're looking for here is we're looking for this b to be equal to 0. So as we solve, these are unlike terms on the left-hand side, so that's an x plus 3. Can't combine those. And we get a y. Now I'm going to flip this entire equation so it's in the same order. So y equals, flip it, x plus 3. Is it true that my plus b is plus 0? No. So this is not proportionate. So this equation is not proportionate because when I solved it for y, I recognize that I do not have a y-intercept of 0, which means it does not go through the origin. All right, next example. Build house, build fence, clean yard, clean yard. So we're going to build a house around y. And we're going to multiply by x, copy, paste, nice and high, nice and high. So we get y equals, so we solve this. We're looking for, do we get y equals mx plus b here? Y equals, so we get y equals 4x. Do I get a plus 0? Is it true that the y-intercept is 0, that it goes to the origin? Yes. So that equation is proportionate. So that really is kind of all the pieces that we're going to cover for today's lesson. We started with graph, then we went to table, then we went to equation. So we're going to try a couple, and then we're out of this lesson already. So here we go. So we have a few to try. Having a hard time moving this. Okay, so question 1, y equals mx plus b. If I put a plus b here, do we have a y-intercept of 0? Yes. So question 1 is a yes, proportionate. Question 2, here's the y-axis. Here's the origin. Does the black line go through the origin? Now I just made it red. Does the red line go through the origin? No, not proportionate. Number 3 says to graph it. Or I can see right there that 0, 0 is going to be on that graph. It's going to land somewhere in there. I will graph it quick though. Left 2, up 1, 2, 3, 4. Left 1, up 2. Right 1, down 2. And you can see that it does indeed go through the origin, so this would be a yes. Question 4, solve for y. This is very similar to the one we just did. But we subtract 3, copy, paste, copy, paste. The problem on the left, those are unlike terms. So that's x minus 3 equals, drag it down. If I'm going too fast, you just simply pause the video. We would need to flip this, or you don't need to, but I'm going to. And we can see that our plus b is not 0, which means it does not go through the origin. So this problem is not proportionate. And question 5, here's the origin. Does the line hit the origin? No, it does not. Not proportionate. All right, crew, we have this left, these 3 left, and we're out. Here we go. So first problem here. Why don't you pause the video and try these 3? All right, so coming back to the lesson, here's the origin. Does the line hit the origin? Does it go through 0, 0? Yes. Here's the origin. Does the line hit the origin? No. Next one, I do not see a 0, 0 in the table, but I'm going to graph it anyway. Left 1, 0. 0, up 1. Right 1, up 2. Right 2, up 3. Does the green line hit the origin? No. So our lesson today is on something called direct variation. Essentially, you're just looking to see, does the line hit the origin? So that's yes if it hits, no if it doesn't. You're also in equation form looking for y equals mx plus nothing. So just a y equals mx, because that guarantees then that your y-intercept is 0. That's it for our lesson today on direct variation and whether or not a table graph and equation is proportionate. Have a glorious night.